this off.
Okay.
Good morning, everyone. I hope everybody is having a great day today. And this morning we're connecting with a mechanical engineer, Patrick Donoughe, but we're going to talk about him here in a second. My name's Nick Pellini, and I work with the Northwest Tri-County Intermediate Unit. And we wouldn't be able to have this partnership with our professionals like Patrick if it wasn't for our Northwest PA Job Connect. Now, that's our local workforce development board, so a special thanks to them. So what we're going to do is we're going to chat with Patrick about his career path, some of these skills that he feels are necessary to work at Komatsu Mining. Somewhere on your screen, we want to encourage you to interact with Patrick, interact with me. So on your screen somewhere, you'll see like a little chat bubble with a question mark in it. That means that you can submit questions to Patrick and ask him about anything, about Komatsu, about his career as a mechanical engineer. But we'll answer those questions towards the latter part of Patrick's interview. And without further ado, we're going to send Patrick live. And Patrick, thank you for joining us today.
No problem. How's it going?
It's going really well. I was trying to stay warm out here, stay warm here, but considering the circumstances. So you're a mechanical engineer at Komatsu.
Correct.
Tell us, what does Komatsu do?
Komatsu, as a brand, is a worldwide company that is actually incorporated in all kinds of things, from construction equipment to mining. I work in the Komatsu mining division. It used to be Joy Global in Franklin, Pennsylvania, and what we do is we have all different types of mining equipment, whether it's the parts that actually mine the ore or the parts that haul all the stuff out of the mine and get it out to the surface so that it can be used in everyday use. I work in the haulage department, which means we specialize in getting the stuff from the mine out to the surface. And that's so that we can get all different types of materials, such as coal or the salt that they use on roads, all different types like that they pull out of mines. That's what we specialize in getting out of the mine in my group.
So you work in a division of Komatsu. I've seen some excavators and bulldozers and stuff with it, Komatsu on the side of it. So you work for the division of Komatsu that specifically makes machinery for underground mining minerals out of the earth.
Correct. Okay. Yes.
Okay.
Yeah. Komatsu acquired. It used to be Joy Global. So Joy Global is actually still the brand that we use because it's a worldwide known branding. But yes, Komatsu acquired them. So we are the mining division of Komatsu. But yes, they do all different sorts of stuff in the Komatsu Unlimited under their umbrella of the full company.
Wow. Okay, so what would you say your day-to-day then, as a mechanical engineer? What is your biggest responsibility there?
As a mechanical engineer there, my majority of my days is working on CAD drawings and 3D models.
What's a CAD? What's that acronym?
CAD is computer-aided drafting. So we're doing 2D, two-dimensional, so flat drawings, and 3D models, which is basically designing parts as they would look in real life, just on the computer. And I do a lot of that. In part, we're doing a lot of design work, so we can either help a customer get the part that they need or the solution that they need for a problem, or to design new parts so that we can develop new products that will help customers in the future, because there's always a need to develop new products, which is where it gets a little bit more creative and a little bit more interesting as an engineer.
So you're not only, most of your work is done on the computer then, the computer-aided drafting?
Yes, a lot of our stuff is done on the computer. We do have, at our facility in Franklin, we do have a shop with people who bring those designs and parts to life in the shop. But as an engineer, we don't really work in the shop. We work with development and design, and then we will go down to look at and test parts of quality and everything once they're built.
Okay, so it's a customer may have the need for a very unique part that you might draft.
Is that correct? Yeah. So An example would be my current project that I'm working on. We just got an order in for a new machine, and I guess I can explain our machine. What it is it's a conveyor belt that follows the miner through. It kind of snakes through the mine with the mining machine, and then once the mining machine dumps that coal or the salt onto the knocks it onto the ground, it gets swept into this machine, and the conveyor will run it up to 500 meters out of the mine. So the current project we're working on, a customer, they say, we want your machine, but we want this added to it. We don't need this. And then we work with the customer to put exactly what they want on the machine, whether it's add-ons or subtracting some things that they don't need in their specific mine.
Okay, so that's a very specific and custom order. So you might draft that and make that into a product essentially on your computer, and then once it's all said and done, what do you do with it? That computer drafting.
So we have so my current, actually the step that I'm in now is the concept design. So we draw up a 3D model of a concept. We actually can place that into a model of the machine and show how it's going to fit, exactly where it'll go, so the customer can say, yeah, I like that, or can we change it to this? So once that concept's done, we will do the costing of all the parts to see how much it'll cost the customer for each additional thing. And then once they agree to that, then what we do is we go in and we actually develop a final design where we say, this is the final design, and then we send those drawings to our manufacturing facilities where they'll actually bring those parts to life for the machine.
Okay. So I want to pause here and speak to our attendees that are we're having some folks jumping in and out. Folks, there's a question and answer bubble somewhere with a question mark in it. So as you hear Patrick talking about anything, feel free to type those questions in and we'll address them towards the end. Okay, so tell us, so now you've sent this away to a manufacturing facility. Is that local? Is that in the States? Is it across the world?
It really depends on what the part is. Sometimes we can order from all over the place. I know we've had stuff come out of facilities in Mexico. I believe we've used places in China. And I think the big factor is a matter of who can do it with the best cost and the lead time, because ultimately you're trying to do the lowest cost and the best lead time while not losing any quality. So you kind of, in the engineering industry, when you start to develop those final products, you look for kind of a mix of cost and quality when you're going to order parts.
Right, because that higher cost that's going to pass on to the consumer.
Correct.
And they want that to be done with those least costs as well.
Correct, but you don't want to sacrifice your quality. So you can go some places you find, and sometimes I've seen in the past in my career that you order parts because of the cost, but if it breaks in half the time that it takes a better quality part, then it's not worth the lower cost to get that part, if that makes sense.
Yeah, certainly. So let's talk a little bit about your abilities. So how did what abilities and interests did you have that you kind of knew you were like, this is the career path that I want to go in?
Yeah, I always loved the sciences in school. Especially when I got into high school, I loved physics, how things worked. I grew up in a small town, and we grew up in a family that couldn't always go out and upgrade every time something broke. So my dad and I, my brothers and my dad would show us how to fix things, and we would try to fix as much as we can at the house. And I really got interested in working on things, and I'm sure my mom was crazy mad when I started like taking things apart and trying to find out how things worked, because then I didn't always know how to get them back together when I was a kid. But I always liked doing stuff like that. Especially, I worked on a Christmas tree farm actually growing up, and we had equipment that we had to use to work on to cut the trees, trim the trees, and everything. And when it didn't work, we had to fix it there for the most part. So I got to work on all different kinds of motors and four-wheelers and tractors. So it just really developed into a love of like working on stuff and figuring things out. And that has also progressed. I also have I kind of do some woodworking on the side. So just working with my hands and trying to develop and design and create things. I was never really good in art class with painting or anything like that, but I I like being creative with how I design and build stuff.
That's great. That's great to hear. Now, would you say most of your work is done independently or as a team?
We have my group is about 6 or 7 people as a team. I work under our lead engineer, and we're the only 2 engineers in the group. And then we have a couple of designers. We have an electrical engineer as well. So anything electrical goes through our electrical engineer. Anything mechanical goes through me and the lead engineer. But then we have designers who actually we'll do the design part, and then we'll give them the models, and they'll do the drawings and turn those into the blueprints to make the part. So it's kind of a mix of both. You have to be able to communicate. You have to be able to, especially now since we're working from home right now with everything going on with the coronavirus. So what we have to do is I have to design a part, and then I have to communicate that, whether it's through a call like this on Teams or it's an email or an instant message. We just have to communicate that to the person who's doing the next thing down the line. There are some group collaborations where me and another guy will work together on getting stuff done, but a lot of times it's you doing something and then passing it on to the next stage.
Okay. I want to shift gears here for a second because you
Sure.
talked about a designer, you talked about an electrical engineer, you're a mechanical engineer. Can you differentiate for those 3? Could you tell us the difference? What's the difference in designer, mechanical, and electrical?
So background-wise, electrical engineer specifically does what it sounds like, electrical work, wiring, circuit boards, programming. The mechanical engineers do a lot of the material design, picking out a material for its properties, what's the strongest material, what won't wear as fast, and also the design portion of it. So electrical engineers will design, but they're going to design like an electrical system and how to run the wires. Mechanical engineers will design the physical parts that are going to be put together to build the machine. And then our designers are actually just really the biggest difference between them. They do some of the same work I do with modeling and design, but a lot of times it's just they did not have the full 4-year degree. They're actually just an associate's degree. So they did a 2-year school to learn how to do computer program or CAD drawing, computer aided drafting and design. So they went to a 2-year school, learned how to do that, so that they're doing similar work to what I'm doing. But a lot of the times we'll take a drawing, show them what needs to change, and they'll actually just make the changes, which they can do, but they don't actually do the full design work.
Gotcha. So that's where the collaboration has to come in, because you may design something that the electrical engineer is like, hey, that's not going to work, because
yes, okay. Probably more often than it should. But we also, it's kind of cool because we have to work together with the electrical engineers where they'll have a system and then I'll make the layout of our machine and I have to incorporate his stuff. And actually a different department has a hydraulics engineer who will do the hydraulics, which is like it's a liquid that'll run your systems with the hydraulic oil. And we have to incorporate all 3 of those systems into one layout because they may overlap each other. We have to figure out how to get them all to fit.
Yeah. So that would be paramount in terms of collaboration, because you have to be working together to make sure that stuff overlaps and fits and works. Wow.
Yeah, definitely.
So you mentioned a little bit about your CAD abilities and your skills. Talk to us a little bit about is that something that's constantly evolving your skills, or is this stuff that you've learned in college and you're good to go? Tell us a little bit about that.
So I actually took a 2D drawing class, which is flat drawings, like making blueprints and sketches in high school. And that was kind of feeding into my desire to do this stuff as an engineer. And then in college, I learned how to they actually taught us how to do it by hand, like they used to do it, hand sketch blueprints. They taught us how to do 2D on the computer and 3D on the computer. But actually, when I started my first job, which was down in Pittsburgh, we did a lot of 2D, but we hardly did any 3D. So when I moved to my new job here at Komatsu, it became a lot more 3D modeling. And then the software is amazing because you can take a 3D model and you can just start a drawing and you can just place that on the drawing and it draws it for you basically. But so my 3D has actually been developing a lot in my new job, because I've learned, and it's ever developing too, like you said, because everything comes out with a new version every year, new features, new ways to do stuff. So you're always constantly learning. But I would say it's been a progression of a fundamental base in college of what it is to do 2D and 3D drawings, and then how to make that work for my specific job as we go on.
So what computer program do you use for your CAD drawings?
So we use Autodesk Inventor for our 3D modeling. What is great about it is they have this thing called the vault. So when you finish a drawing, you can check it into the vault, and then anybody in the company that has access to the vault can actually pull that drawing out. So if I make a model and I put it in the vault of like one of the components, my electrical engineer can pull it out and see how his component fits on it, and then the hydraulic guy can pull it out and see how his component fits on it. So it's a really adaptable, usable program for like the whole company. We also used AutoCAD. We don't really use that too much, but there's an AutoCAD is the program name, and Pro Engineer is the 3D modeling I used in college, but we don't really use that at Komatsu.
Okay. So if you're posed with a custom order or something like that, and it just doesn't exist, the part that somebody wants, what kind of thought processes do you go through in order to bring this part to life, to make it work? I mean, there has to be a lot of problem solving and critical thinking. Where do you go to figure that out?
So everyone has their own kind of process. I like to personally, since I kind of have more of a background in tinkering with stuff at my house and learning that background, I like to just kind of sketch it myself on a piece of paper and just kind of get an idea design down. But the big thing is you have to really look at where you're putting this part, because a lot of times the parts are going to fit into something else. So you might have a space that's this big around, and you have to fit something in that space that does what you want it to do. So you have to look at where you can mount it, how you're going to mount it. Is it going to get welded on? Is it going to get bolted on? You have to look at making sure, like we have, since it's a conveyor belt, we have a lot of moving parts, a lot of the belts moving, and the belt's one of the most expensive parts of our machine. So you can't afford to dig into the belt or ruin the belt. So you really have to look at how things are going to lay out. But yeah, I'd say I start with like a hand sketch of what I want it to look like, and then I actually look at the spacing that I have, and then I get an idea of my constraints on. If I know that I only have 2 anchor points, then I have to start with that and base it off of where those 2 connection points are going to be to mount it.
Okay, so all that information comes in like an order from a specific company. They say, we have 2 anchor points. It can only fit. It needs to fit within this.
Yeah, well, a lot of times this is what we want. In this company, a lot of times this is the thing that we want. This is the idea that we want to have. Can we do it? And that's where we come in and say, yeah, we actually have the space. I can make that work right here, or we can't fit that here. And if we can't fit it, and they really want something like that, a lot of times we'll try to find a different solution for them, which is another part of that creativity side, trying to find another way to figure out their problem.
That's cool. That's cool. I want to throw it out there to the audience again. Remember, we're going to be shifting to our question and answer here in a little bit, but if you have any questions for Patrick about his company or his goings on, feel free to throw those into the question and answer. Patrick, talk a little bit about your education.
Sure. I grew up in South Central PA and went to public high school. Was very blessed there that we had some like engineering type classes. I took AP Physics, but I was able to take like a CAD drawing class, like I said. So if you're thinking about engineering, I would say that if you have those opportunities in your high school, definitely take advantage of it, because it kind of gets you set ahead for college. I went to Grove City College and started out that career started out with a lot of physics and like base classes, but they have a really great program in mechanical. They actually have mechanical and electrical when I was there, and they've added chemical engineering. So they're really expanding their stuff there. But it's just a lot of the classes are a lot of math-based, calc-based, and science-based classes. You go through stuff such as material properties, like what materials do what, and is it better for wear resistance? Is it better for heat resistance? Stuff like that. And then you do a lot of actually do a lot of heat transfer, and then you do a lot of, they call it statics and dynamics, are basically physics on steroids, if you want to call it that. It's basically taking physics principles and incorporating them into engineering principles. So that's kind of the base of the mechanical engineering program.
Okay, and your position, I imagine, to have a mechanical engineering degree to work in your position.
My position, yes, mechanical engineering degree. Like I said, we have some people who have 2-year associate's degrees that do the drafting in CAD. We have electrical, we have hydraulics. So, but yeah, for my specific position, yes, mechanical would be the position.
Cool. So tell us one fun thing or something that's happened to you throughout your career. You're like, wow, that's interesting, or that's really cool. You know, an interesting experience, just something fun. Elevator.
Yeah. So my old job was working in the combustion field, which is, we used to make burners for steel furnaces. So we would make the thing that heats up the furnace. And I just remember my first position, or my first big test there was a job that does, it was about 18 million BTUs, which is really, really big burner. But there was a job that came through, and it was for this specific job in China. And I worked on the whole project and did all the development, and it got sent over to China and it didn't work. So I actually got sent to China to work on that and to work in and figure out why it wasn't working, since I was the one who did all the work in the lab. And it was really cool because I got to go over in about April, figured out what was wrong, came back, figured out how to fix it, and then I actually went back in August and implemented the solution. So that was like a really cool start to finish experience for me.
That is really cool. So what did you think of China?
It was interesting. Yeah. The flight was the worst part. It was about 14 hours. But it was neat. I got to try a lot of different things, a lot of different food. I actually got to I spent a day off and went to Disney in Shanghai. So Disney World in Shanghai. So that was pretty neat. But
that's cool. So you had mentioned that if somebody was interested, whether middle school kiddo or a high school kiddo, if somebody was interested in thinking about a career path in engineering, you had mentioned that take some computer-aided drafting classes and things like that in high school. Is there anything else off the top of your head, like web-based or free, that kiddos could tinker with?
I mean, I would just say, first off, the biggest thing is to push yourself, because if you're going to be an engineer, I know Grove City for me was I also played the sports in high school, and I played football at Grove City. So I was trying to learn to balance, but I think that was really important to learn that balance, because I would say if you are interested in things, try to push yourself. If you're going to be an engineer, or if you want to be anything really, push yourself to challenge yourself. Don't just sit back and say, I can scoot by high school, because when you get to college, it really kicks your butt sometimes with the different classes, all your things hitting at once. But like if you have hobbies, I would say try to balance those so that you learn that time management, and that you learn how to handle things. Because when you get into the field, my old job I used to do it, this job I do, I think it's pretty much any position, engineering or otherwise, is there's a lot of, you get several projects going at once, and you have to manage those. You have to learn how to prioritize and put your time where it needs to go. So just pushing yourself to be active and be challenged, whether it's sports, whether it's your art or your music, and on the side, learn how to balance that so that you can get everything done, but you can also learn that balancing. That's probably the biggest thing that isn't even class related, is just learning how to balance things and prioritize so that you don't get overstressed with stuff. But I know for myself, I like puzzles and games that really challenge your mind. I like to tinker with stuff like that outside. my wife jokes with me because I have a Sudoku book sitting on my office desk, and I play it on my phone all the time, and just trying to continue to sharpen your mind. So, yeah, I would just say just continue to challenge yourself is probably the biggest advice I have. And if you have those classes in school that are AP classes or honors classes that are going to challenge you, you might be used to getting A's, and you might not get an A in those classes, but I'm going to promise you'll learn a lot more in those tougher classes than you will taking the easy ones.
All right. It seems to be a common theme that we get from a lot of our professionals, is that get comfortable with the uncomfortable.
Yeah.
Pushing yourself into learning and new designing and finding new solutions. So now I want to throw it out there to the audience. There's a bunch of different free, like Google SketchUp is a computer-aided drafting. You can go on and tinker with those things for free. And when you graduate up to something like Patrick's using, those are often pricey tools that private organizations such as Komatsu use to do all their designing. But there's free stuff out there. Patrick, any parting words with our audience out there?
No, just like we said, just continue to challenge yourself. Continue to work hard to what you want to do. I know a lot of people I went to school with who graduated with engineering degrees that they were told they weren't going to be able to handle it when they were in high school because they weren't smart enough or didn't have what it takes, But if you put your work in, you'll be able to get to what you want to do.
That's great advice. So, folks, I want to say thank you to everybody who's connected today, and special thank you to Patrick for connecting. He's a super busy guy. And I also want to point out that we recorded the session, and we will have this recording posted on our website, so keep an eye out there. And for all of you out there aspiring to be engineers, stay with it. And thanks for connecting today, guys.